So far, we saw that if we have a differential equation with constant coefficient, we can form auxiliary equation using y equals to e to power mx. The auxiliary equation is am squared plus bm plus c equal to 0, and you end up with three cases. In case 1, you have distinct real roots. The general solution can be written as c1 e to power m1x plus c2 e to power m2x. The second case is where you have repeated real roots. The general solution is c1 e to power m1x plus c2 x e to power m1x. And finally, when you have complex root, you end up with solution, general solution y equals to e to power alpha x c1 cosine beta x plus c2 sine beta x. Now suppose you have higher order differential equation with constant coefficients. The fourth derivative of y with respect to x plus 2 times the second derivative of y with respect to x plus y is equal to 0. The auxiliary equation is m to the fourth plus 2m squared plus 1, which is m squared plus 1 to the second power equal to 0. So please pay attention here. It has roots m1 and m3 equals to I. When you set m squared plus 1 equal to 0, m squared is -1, so m is square root of I. And please note that it has exponent 2, so you get repeated solutions, right? I and -I are going to be repeated. It means that you're basically dealing with a combination of the third case and the second case. From case 2, the solution is c1 e to power ix plus c2 e to power -ix plus c3x e to power ix. Again, remember that I is repeated solution. So you're going to have c1 e to power ix, c3x e to power ix, and c2 e to power -ix, and c4x e to power -ix. It doesn't matter if you have a real solution or complex solution. As long as you have repeated solutions, it means that you have to have x present. Now, by Euler formula, c1 e to power ix plus c2 e to power -ix can be rewritten as c1 cosine x plus c2 sine x. Similarly, x times c3 e to power ix plus c4 e to power -ix can be expressed as x c sub 3 cosine x plus c sub 4 sine x. Well, if you just go back to y up here, rewrite the whole thing in nicer form, the general solution is c1 cosine x plus c2 sine x plus c3x cosine x plus c4x sine x. So as you can see, here you have the fourth order differential equation, and you end up with 4 solutions. And these solutions, they are all linearly independent from each other. It means that it forms a fundamental set. You can basically find the Wronskian and find the determinant and easily calculate the determinant and show that they are linearly independent from each other.